Mr. Heffron here. Here's a video on energy solutions related to climate change. Okay, so first of all, energy allows us to live much more comfortably than previous generations of humans. We do not need to be nomadic hunter-gatherers struggling for survival. We do not even need to be subsistence farmers riding ox carts, using candles, pumping water by hand. We really do have it easier. If you just take a look at humanity's history and prehistory, approximately maybe 1 million years ago, people had fire for the first time. And then they developed candles about 1800 BC. Then there was the oil gas lamps. Finally, we had incandescent lamps, fluorescent lights, CFLs, and then finally LEDs. And you can carry this giant light source right here, and on average a human being has about 16 million times more ability to make light than a cave person. So it's just amazing if you look at just light. Other things we do for energy as well is we get water with energy, we travel with energy, we cook our food, heat our homes. There's all sorts of important things we do with energy. You can see the evolution of how we got water before. Okay. How we traveled, how we cooked and heated. It's just amazing, our progress there. So it mostly started, big changes occurred with the Industrial Revolution around 1750, and it took a while though before we noticed them. So first humanity was using wood, and so you would make steam with wood. Then they moved on to coal, and then by 1820 we were using oil and natural gas, and then nuclear energy starting in 1945. And then we started developing some renewable energy resources in 1970 with solar power. And then finally we had high-speed internet, or you can call it high-speed, I guess, in 1995. In 1992, it would take me half an hour just to download a single picture on the internet. These days, it takes a split second. So the internet is so fast these days. So as you can see in this graphic, how we've changed and what we do. And then over here, you can see when we started using certain kinds of energy sources. So biomass would mostly be trees at this point in time. And then we started using coal, and it picked up. Then we started using oil around here, and significantly by here, 1960. Natural gas, hydropower started also around this point in time, and then nuclear power up here, and then we have other renewables. And you can see the major inventions: steam engine, electric motor, gas engine, vacuum tube, which was the old computers from a long time ago, commercial aviation, television, nuclear energy, microchips, and now the internet. So we have exponential use in energy and our sources of energy as well. So non-renewable energy resources, let's take a quick look at them since they've got us to where we are. There's a limited supply. Eventually we will run out, and most of them tend to be dirty. They cause pollution, which harms the world that we live in. So they are hydrocarbons. They're made of hydrogen and carbon, and we used to call them fossil fuels because most of them come from dead trees that died millions and millions of years ago. And an example would be methane. Methane is 1 carbon attached to 4 hydrogen. These days we just call fossil fuels and hydrocarbons carbon. It's just easier. But most of our energy did come from the sun, and was formed from photosynthesis of sunlight. So here you got the sun, grew into forests, trees. They died, formed coal, petroleum, natural gas. And then besides that, we also have uranium in the ground. That's the heaviest naturally occurring element that we've found on the planet, and we've been able to use that for nuclear fission. So coal is a big driver of the Industrial Revolution from 1850 to now. It's the oldest source besides wood, was the only thing older, and animal oils. Most carbon dioxide pollution has come from burning coal. And it also is the main cause of acid rain, which was cleaned up finally in the 1970s and 80s. Still very abundant and cheap. If you go to developing countries like China, you can see the smog and the pollution in the cities like Beijing, thanks to all the coal they burn and all the traffic. It's very abundant. According to the Ecotricity website, at least 75 years left. The U.S. government says there's 180 years worth of reserves and 250 years worth of recoverable coal. You got lignite, very, very bad for pollution. Germany uses this one here. Anthracite, bitumen, which is more what you'd find in Canada, and subbituminous. You can see strip mines do terrible damage to the environment, take thousands and thousands of years to recover from that, and you can see some of the effects of acid rain as well. Okay, so coal's not too clean. It's very, very dirty. Petroleum oil, 1920 to present, best energy source for automobiles until 2020, when electric vehicles finally became equally efficient and able to travel as far. So you got ICE, which is internal combustion engine that uses oil or petroleum or gasoline, and then you got EV, electric vehicles. That's your hybrids, your lithium-ion, and your fuel cell vehicles. It's very geopolitical oil. It's needed for modern war. You can't run your tanks without it. You can't run your destroyers, and it's also used to produce plastic and many other petrochemicals like food dye, fertilizer, etc. I misspelled limited here. So according to websites, we have about 55 years of useful oil left. We should run out around 2051. There always will be oil. The thing is it worth taking out of the ground? Eventually it just becomes too expensive, so we only have 55 years of cheap, affordable, or easy to get oil. After that it's going to be very expensive. Still pretty cheap. If I just went back to coal for a second, you can see that it costs $100 million to make a power plant with coal, and it's only $40 a ton. But you get 670 megajoules for a US dollar, where with oil you only get 34 megajoules. So you can say that oil, even though it is cheap, it's coal's 20 times cheaper than that. It's very bad for the environment, leads to carbon dioxide, smog, plastic. There's in the ocean, there's places like this where there's so much plastic, it's like the size of Texas. It's ridiculous. Oil spills, and it's even been linked to obesity when you're changing hormones in the human body. The microplastics can get into and cause you to have obesity issues. And they've even found microplastics now in the placenta for the first time this year in 2021. Natural gas, also mistake there, it shouldn't be radioactive. So natural gas from 1920 to present, it's the cleanest carbon energy source we've got. It's used for heating and cooking mostly, sometimes for vehicles. Used to gaslight cities starting in 1785. Instead of electric lighting, they had gas lights back then. It was someone's job to go around and light the lights. It's very geopolitical since Russia controls most of Europe's gas supply, and they do use supply and demand economics to control Europe a little bit. Semi-abundant, we got like 65 years left to around 2061. It's pretty cheap. You get 155 megajoules per dollar. It's not as cheap as coal, but it doesn't pollute as much, so it's worth it. And there you go. Then we got nuclear fission. Nuclear fission, old large plants, the old technology starting from the 1950s till now. It's climate change clean. There's no carbon dioxide, but there is radioactive waste, which has a 1 billion year half-life. And you also have a small risk of a nuclear meltdown, especially in older plants. And there has been mistakes, like Chernobyl was the worst nuclear accident in history. Fukushima in Japan recently, a tidal wave hit the plant, and it was horrible. And some countries like India used Canadian power plants and retooled them to make nuclear weapons, or weapons of mass destruction. Okay. Oh, sorry, I go back there, and it costs a lot of money. It's like over $10 billion to make a power plant, so that's 100 times more expensive than a coal plant. But the energy is cheap, 40 bucks for a kilo, and you get 80 million megajoules for a US dollar. So there's some good videos on on extreme engineering. They talk about how many years a power plant has to be to run to make itself worth it compared to coal, and it's pretty interesting. Okay, so finally we get into renewables, and I think we'll do this in our next video.